Hello, good morning, good afternoon, good day, depending on where you're watching this video. Thank you for passing by to watch my video. We want to look at the topic in mathematics. We call it mathematical induction. If you're in the university, you see this topic in logic and linear algebra. So it's an opportunity for you to learn online how to handle your logic and linear algebra problems when it comes to mathematical induction. What is mathematical induction? Mathematical induction is a proof technique used to validate or prove the validity of a mathematical statement. Now, when we talk about mathematical statement, we are talking about statements that has to do with mathematics. Now, for all natural numbers, there are steps that are necessary to validate or to prove that a statement has been proved by mathematical induction. One of the steps is called the base case. In the base case, you assume that n is going from 1, 2, 3, 4, and so on and so forth. You have to test those numbers to see if they satisfy the 10 formula. Secondly, you have the inductive step. In the inductive step, it is presumed that you assume an arbitrary constant. Most times you call it k. You impute the arbitrary constant into your statement, then increase the statement by k plus 1 and prove to see if the right hand side is gone to the left hand side. Once the right hand side is gone to the left hand side, it has been said that you have proved by mathematical induction. Without wasting time, I want to look at an example. Example 1. We want to prove that the natural counting numbers, we know 1 plus 2 plus 3 plus dot 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 plus n is equal to a 10 formula. Let's call that 10 formula n into n plus 1 divided by 2. We want to prove this. The first thing we do is to say that let n be going from 1, 2, 3, and so on and so forth. Now, if n is going from this, at n is equal to 1, at n is equal to 1, what are we going to do? We are going to say that 1 is equal to the 10 formula. The first one there, which is 1, is equal to the 10 formula, which will give us, at n is equal to 1, we have 1 into 1 plus 1 divided by 2. That will give us 1 is equal to 1 into 1 plus 1 is 2 divided by 2. 2 will cancel 2, we have 1 is equal to 1. Secondly, you test for n is equal to 2. At n is equal to 2, this is the first one, this is the second one. So we now say 1 plus 2 is equal to base. Here you have n is equal to 2. So anywhere you see n, you put 2. So you have 2 into 2 plus 1 divided by 2. That will give us 3 is equal to 2 into 2 plus 1 will give us 3 divided by 2. This cancel this, we have 3 is equal to 3. Finally, we have at n is equal to 3. At n is equal to 3, we have 1 plus 2 plus 3 is equal to, when n is 3, substitute there, you have 3 into 3 plus 1 divided by 2. So 1 plus 2 plus 3, that will give us 6 is equal to 3 into 3 plus 1 will give us 4 divided by 2. Of course, 6 is equal to 4 divided by 2 will give us 2. 2 times 3, that will give us what? 6. You can do that for 4, 5, 6, 7, and so on and so forth. But why do that when we can assume a constant k, an apparent constant k? Now, what we assume that n is equal to k, since we cannot do this continuously. Now, let n be equal to k. That means we are replacing n here with an arbitrary constant. That arbitrary constant stands for those terms that we don't know of. Now, if n is equal to k, we can write this as 1 plus 2 plus 3 plus dot 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 plus k is equal to k into k plus 1 divided by 2. Again, increase k by k plus 1. So that means we let n to be equal to k plus 1. So if we let n to be equal to k plus 1, we are going to have 1 plus 2 plus 3 plus dot 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 plus k plus the increment, we have to add it, which is k plus 1, is equal to For the left hand side, anywhere we see k, we replace it by k plus 1. So we have for the first k here, we have k plus 1 into, for this k, we have k plus 1. I will enclose the bracket inside plus 1. All of this divided by 2. Now, at this point now, let's reduce the mathematical statement. How do we do that? We can recall here that the whole of this statement is equal to this. So instead of writing this from here to here, we can replace it with this. So replacing that, we are now going to have k into k plus 1 divided by 2, which is this, plus k plus 1 is equal to this, k plus 1 into, if you open this bracket, you have k plus 1 plus 1, that is k plus 2 divided by 2. From the left hand side, you can find the LCM. Finding the LCM in the left hand side, the LCM, you know, the denominator here is 1. Any number divided by 1 is still that number. So the whole of these terms, k plus 1 divided by 1 is k plus 1. So the LCM here is what? 2. 2 divided by 2 will give us 1. 1 times the whole of this will give us the whole of that. So we have k into k plus 1 plus 2 divided by 1 will give us 2. 2 times the whole of this will give us 2 into k plus 1, which is equal to k plus 1 into k plus 2 divided by 2. Now, at this point, we can factorize this. If you've done quadratic equation and use factorization method very well, you know what I'm talking about. But if you've not done that, that will be another topic for another day. So since these two terms are the same, we are going to write one k plus 1, and we take this and this. We have k plus 2 divided by 2, which of course is equivalent to what we have at the right hand side. Since the left hand side is equal to the right hand side, mathematically, we've been able to prove using the concept or the principle of mathematical induction. Example 2. Let's use a different mathematical statement. 3 plus 7 plus 11 plus plus, let's use 4n minus 1, and we can equate this to n into, let's say, 2n plus 1. You can prove this. Now, if you look at this, it's also a mathematical statement. Now, the first thing we do, without wasting time, is to test for n equal to 1, 2, and 3, and see if it holds. So, for the first term, at n is equal to 1, the first term here is 3, which is equal to the term formula here. So that means we are going to have n is going from 1. So anywhere we see n, replace it by 1. So we have 1 into 2 multiplied by 1 plus 1. So 3 is equal to 1 into 2 times 1 will give us 2. 2 plus 1 is 3. Of course, 1 times 3, that will give us 3 is equal to 3. That has been proven. Let's look at the next one. At n is equal to 2, we have 1, 2. That means 3 plus 7 makes it the two terms in consideration. Is equal to, anywhere we see n, we put 2, so we have 2 into 2 multiplied by 2 plus 1. 3 plus 7, that will give us 10, which is equal to 2 into 2 times 2, that will give us 4, plus 1. Of course, you know it's 5. So 10 now is equal to 2 times 5, that will give us 10. That have been satisfied. We look at n is equal to 3. At n is equal to 3, we have 3 plus 7 plus 11 is equal to, n is 3. So we have 3 into 2 into 3 plus 1. So 3 plus 7, 10, 10 plus 11, 21 is equal to 3 into 2 times 3 is 6. 6 plus 1, that will give us what? 7. So 21 now will give us 3 times 7, that is 21. It has satisfied the first 3 terms. Now, let's look at the inductive case. In the inductive case, what do we do? We say, let that same n be equal to k. Replace, anywhere we see n, we put k. So we are going to have 3 plus 7 plus 11 plus dot 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 plus 4k minus 1 is equal to k into 2k plus 1. Again, we say, let, we have said n is equal to k, we have this. Now we say, let n be equal to k plus 1. So if n is equal to k plus 1, we are going to have 3 plus 7 plus 11 plus dot 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 plus 4k minus 1 plus we now have 4 into k is k plus 1, then minus 1. All of this is equal to k plus 1 into 2 into k plus 1 plus 1. We have increased k by k plus 1. We can recall that the whole of this statement from here to here, from here to here is equal to this. So from here down, from here to here, we can replace it by k into 2k plus 1. So we are going to have k into 2k plus 1, which is this, plus this will give us 4k plus 4 minus 1 is equal to k plus 1 into 2k plus 2 plus 1. So this will give us k into 2k plus 1 plus 4k plus 3, which is the same thing as k plus 1 into 2k plus 3. Let's open this bracket. We are going to have this times this will give us 2k squared plus this times this will give us k plus 4k plus 3, k plus 1, 2k plus 3. Adding this, we have 2k squared plus 5k plus 3 is equal to, this will give us 2k squared plus k multiplied by this, that will give us 3k plus 1 multiplied by 2k, that will give us 2k plus 1 multiplied by 3, that will give us 3. 2k squared plus 5k plus 3 is equal to 2k squared plus 5k plus 3. The left hand side come to the right hand side, which shows that the statement have been proved by the concept of mathematical induction. Let's look at example 3, already on the board. Now we have 1 cube plus dot 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 and so on and so forth. It's called to this 10 formula. The first thing we do is to let n be equal to 1, 2, 3, and so on and so forth. Here we just stop as 2 because of time. So if we have n is equal to 1, that means the first term, 1 cube is equal to n is 1, so we have 1 squared into 1 plus 1, all of this square divided by 4. So this will give us 1 is equal to 1 into 1 plus 1 is 2, 2 squared is 4 divided by 4. This will cancel this, we have 1 is equal to 1. At n is equal to 2, we have the first term plus the second term, basically n is equal to 1, 2, is equal to, n is 2, so we have 2 squared into 2 plus 1 squared divided by 4. 1 cube will give us 1 plus 2 cube, that will give us 2 times 2 times 2, 2 times 2, 4, 4 times 2, 8 is equal to 2 squared, that will give us 4 into 2 plus 1, 3 square divided by 4. 1 plus 8 is 9 equal to 4 into 3 square is 9 divided by 4. This will cancel this. You have 9 is equal to 9. Let n be equal to k. So we have 1 cube plus 2 cube plus dot 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 plus k cube is equal to k squared into k plus 1 all squared divided by 4. Let n be equal to k plus 1. If n is equal to k plus 1, we are going to have 1 cube plus 2 cube plus dot 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 plus k cube plus k plus 1. We are increasing k by k plus 1 raised to the power of 3 is equal to k plus 1 all squared into, for this k, we have k plus 1, then plus 1, all of this squared, divided by 4. You can recall that from here to here is equal to this. So in place of this, we write this. So we have k squared into k plus 1 all squared divided by 4 plus k plus 1 raised to the power of 3 is equal to k plus 1 all squared into, if you open this, we have k plus 1 plus 1, that is k plus 2 all squared divided by. Let's look for the LCM of the left hand side. For the LCM of the left hand side, we have the LCM here as 4. 4 here divided by 4 is 1. 1 times the whole of this will give us k squared into k plus 1 all of this square plus 4 divided by 1 is 4. 4 times this will give us 4 into k plus 1 raised to the power of 3. This will give us k plus 1 all squared into k plus 2 all squared divided by 4. Moving forward, we then multiply the numerator by 4. We'll multiply the numerator by 4. 4 will cancel 4, and 4 will cancel 4. So we have it only the numerator, which is k squared into k plus 1, all of this squared, plus 4 into k plus 1, this power of k is equal to k plus 1 squared into k plus 2 squared. Now, at this point, we can decide to do a little bit of factorization. K plus 1 squared is common between them. So we have k plus 1, all of this squared. So what we left there is k squared plus, we'll be left with 4 into k plus 1 squared is out. So we have k plus 1 is equal to k plus 1 all squared into k plus 2 all squared. So here we are going to have k plus 1 all squared is equal into k squared plus 4k plus 4, k plus 1 all squared into k plus 2 all squared. At this point, we factorize the quadratic expression here, which is going to give us k plus 1 taking all of this squared into k plus 2 into k plus 2. That is the factorization of this. That is to give us k plus 1, all of this squared, into k plus 2, all of this squared. So we are going to have k plus 1 squared into k plus 2 squared, which is equivalent to k plus 1 squared into k plus 2 squared. From here, it is clear that the left hand side is equal to the right hand side, which proved by the principle of mathematics. Please kindly subscribe to our YouTube channel at FYOMKIT, and also on Facebook. Follow us on Facebook, like and share. Thank you as I look forward to seeing you on our page.